Welcome DP Sogong aboard. Your learning journey starts now. Ever felt like math proofs are just black boxes? What if the real story isn't in the symbols, but in why we prove things? Forget the old way where standard math was the final boss. Enter Duan's WMesh 5.9, flipping the script entirely. So how does this new framework work? It's built on the Oblivion model: data, information, knowledge, wisdom, purpose. Think of it as the blueprint for a proof world. Data is your raw stuff, numbers, examples. Information is the relations between them, same, different, connected. Knowledge is the formal rules, axioms, theorems. Wisdom is the big picture, what-if scenarios, limits, repairs, and purpose. That's the why. Why are we even doing this proof? Crucially, these aren't steps you climb. They're interconnected elements in a dynamic web. A change in purpose can ripple through and affect what data is relevant. Okay, so where does traditional formal math fit in this grand scheme? Brilliantly. Duan's system doesn't ditch formal math, it elevates it. Think of ZFCP Lean Isabel. These rigorous systems become highly detailed local maps, specifically within the K element of DIKWP. The symbols go into D, the axioms and theorems into K, the rules into I, and importantly, the scope, limitations, and countermodels get mapped into W and P. This leads to a killer insight, the no global reduction theorem. Two proof worlds might have identical formal conclusions K, but if their purpose or wisdom differs, you can't perfectly merge them by only looking at K. Trying to force everything into one formal system. Lossy compression, folks, and crucially, if something isn't proved in a formal system yet, that's just a local silence, not an automatic global refutation. The burden of refutation shifts. So what makes a Duan proof complete? It requires passing 10 semantic gates simultaneously. Think of it as a 10-part checklist for building a truly robust understanding. You need a clear purpose covenant, solid encounter traces, well-defined relations, object or type genesis, a working mechanism, a considered counterworld, successful cross-atlas transfer, mechanisms for misunderstanding and repair, acknowledgement of a semantic remainder, and a final interpretive power audit. Miss one? You don't get a pass by acing others. It's non-compensatory. Formal proofs can be witnesses, but they're not automatically sovereign. If the purpose is semantic understanding, formal tools are helpers, not the boss. Under this protocol, three major conjectures, Strong-Goldbach, Collatz, and the four-color theorem have been registered as Duan semantic proof complete. P versus NP gets a nuanced status, branch complete, no global section, reflecting the different resource assumptions. This isn't about saying mainstream math is wrong, it's about separating formal closure from complete understanding. Many famous theorems are formally closed but lack the full Duan semantic world, hence alignment pending. Conversely, problems unsolved formally, like Goldbach and Collatz, can achieve completion under Duan's own rules. Of course, there are risks. Misusing the framework as immunity, ensuring consistent object definitions, and preventing new power imbalances. But the core idea is powerful, a higher dimensional atlas embracing multiple local views. So the big takeaway? Formal mathematics is not the whole truth, but a vital local map within a much richer semantic landscape. Just because something isn't derivable in one formal system doesn't mean it's globally false. Duan's mathematics offers a master atlas perspective. It's a shift from one-way submission to a mathematics-first framework. Now go forth and rethink those proofs.